Hello all. In this video I am going to show you Arduino Uno as a counter. So as you can see here, this is my Arduino board. This is my Arduino board and this is my counter. The counter is continuously incrementing. The counter is continuously incrementing. You can see here the counter values are incrementing, okay? Now you can see here I am using serial in parallel out combination of the Arduino Uno. Arduino Uno is sending one serial data and another clock data. The white wire is the serial wire and the black wire is serial data wire, and the black wire is the serial clock wire. Okay, so data is traveling from the white wire and the clock is traveling from the black wire. So they are being fed here in the Arduino Uno board, in the breadboard, and it is fed to the shift registers. You can see the shift registers down. You can see the ICs down. So these are the shift registers. Okay, so the clock and data is being fed. Now this is a combination of serial in parallel out application. So serial data is fed in and parallelly we are getting the data, and the data is being fed on the display. So basically I am transmitting this 1388 serially from the Arduino Uno, and it is displayed in parallel mode on the 7-segment display. Now let's have a look on the software. So as you can see here, this is my software. As you can see here, this is my software. So I will show you the software here. So you can see here, this is my 7-segment display combination. As you can see here, this is the 7-segment display matrix. See, when it is getting 1, what value it has to show serially, it is fed here. See, this is for 0, 0C0, 0F9 is for 1, 0F4 is for 2, like that up to 9. 0 to 9, all the values are fed here in the integer array. You can see this is an array of 10 elements. Okay, so what I am basically doing, I am basically defining a counter, count equals to 0. So this is a counter. The initial value of the counter is 0. Initial value of the counter is 0. So I am defining the pins. You can see here, the latch pin is pin number 8, the clock pin is pin number 12, and the data pin is pin number 11. So latch pin I am not using. I just defined it. I am not using. I am only using clock and the data pins. Okay, so now you can see on the loop, you can see this is my loop, main loop. So in my main loop, what I am basically doing, I am basically incrementing the count from 0 to 1, 1, 0 to 1, 2, 3, 4, it is adding. See, count equals count plus 1, means it will keep on adding. And now I am, for the display, I am segregating the values. See, count equal count divided by 1000, it will give us the value, it will give us the thousands value. Count divided by 1000 will give us the thousands value, and the count percentage 1000 will give us the remainder of the value. So like that the calculation is being done here. This is the calculation block, and after the calculation block, this is my display block. This is the most important part. You can see here digital write clock low. So I will select the clock pin as low. First clock pin will be low. Then I am going to shift out the data. Shift out data pin, clock pin, MSB first, J, count underscore 1 underscore R. This count and 1 underscore R is this value. You can see here this value. This is the value. You can see this value, this count underscore 1 underscore R. I will be pointing here. So this element of the array will be displayed. See, you can see here, this whatever value will come here, 1, 2, 3, whatever. So jth element of that array will be displayed. So if we go to the jth element, if we go to the jth array, you can see, suppose that value what I am calling, if it is 0, it will call 0C0, the first element. So like that it will be there. This is an application of C programming and array. Okay, now you can see here what I am basically doing. I am shifting out. Shift out is the Arduino command. Shift out data pin on the data pin, and the clock pin, clock and data both will be having the data, and the MSB bit will be sent first, and this is the what data I have to send. J equal to count underscore 1 underscore R or whatever, like the jth element of the array. Okay, like the nth element of the array, I mean. So after this I am calling a delay of 1000 millisecond. So this is the incrementer. Okay, so after 1 second, 1000 millisecond is 1 second. So after 1000 milliseconds or 1 second, it will come back to this loop again, to the initial part of the loop, and it will keep on counting. So this is an auto counter, auto increment counter. It is incrementing by itself, as you can see. Okay, so this is all about the software, and this is all about the video. Again, I am going to show you my counts. So now you can see here it is showing 1632. Okay, so it is showing 1632. So this is all for today. Thanks a lot. Thanks for watching. So this counter, however, can be made an incremental counter from external source. Presently here I have used, in the software it is counting by 1. You can see count equals to count plus 1. You can see in the software it is counting. Okay, instead of this count equal to count plus 1, instead of this count equal to, wait, undo. So instead of this count equal to count plus 1, I have to feed the value from external source. With the external source, it has to increment, not like this in the loop. Okay, so that modification I will do, and I will implement another video. I will implement another video and I will upload. So this is all for today. Thanks a lot. Thanks for watching.